Everyone. So today's topic is going to be operation on numbers, and in this particular chapter, we are going to learn a lot of things related to algebraic formulae, the concept of Bode-Mass, the indivisibility of algebraic expressions, and then in the end part we'll see something called as binomial expansion. So this topic is full of formulae. So make sure you're on board with the whole idea. So let's first start with the idea of Bode-Mass. Now, most of you are aware about the Bode-Mass concept. That is, if let's say addition or subtraction or multiplication or division is given altogether, then obviously multiplication and division has more priority compared to addition and subtraction. Addition and subtraction has always the last priority of least of importance. So we have to always do them in the end part. So the idea is Bode-Mass is something that you are aware of, but here what we are doing is we are slightly refining that, and hence going forward you're gonna remember one new priority. So instead of Bode-Mass, it is going to be V Bode-Mass. Now what are these terms? So V is obviously vinculum. Vinculum is basically the bar sign that you probably has seen on recurring denominators, recurring decimals, sorry. So let's say for example 0.3 bar, which means 3 is gonna get repeated infinite number of times. So that bar sign is something called as the vinculum. The bar sign is something that is called as the vinculum, basically. So we have to remember that. So vinculum has the highest priority. Then after that, obviously, O, that is B, that is brackets. Then O is for off, which is multiplication, normally powers, roots, etc. Also, then DNM, division and multiplication, left to right, whatever is the first. And then lastly, something called as addition and subtraction. So these are the priorities. Bode-Mass, as I said, just add one more thing to that. That is vinculum, which is V Bode-Mass going forward. So that's gonna be the priorities that we are gonna be dealing with, and we are gonna use that when we are gonna solve the questions basically. Okay, so now let's continue with the formulae. A lot of them you would have done in the school days. So gonna be a quick recap of all the things. So the first one, that is a plus b the whole square. It is a square plus b square plus 2ab. Then a minus b the whole square. It is same thing, but only the second term, the middle term, is minus 2ab. Then the third formula, a plus b the whole square and a minus b the whole square. That means we have to add these two. So if we have to add these two, then obviously we have to add the left hand sides also and the right hand sides as well. If we add the right hand sides, what you end up realizing is that you get 2a square plus 2b square, because plus minus 2ab gets cancelled off. Then similarly, the fourth one is we have to subtract both the formulae as well. So if you subtract them, obviously what will happen is plus minus a square and b square will cancelled out each other, and this minus 2ab becomes plus 2ab. So you get the answer as 4ab as the formula. Then there is fifth one now, a plus b plus c the whole square. So it is based on a plus b the whole square. So you can look at that formula and then probably understand this. So it is a square plus b square plus c square plus 2 times ab plus 2 times bc plus 2 times ac. Then you have a minus b minus c the whole square. It is basis a minus b the whole square. So if you look at that formula and compare, you will get a square plus b square plus c square minus 2ab plus 2bc and minus 2ac. So that's the formula for the sixth one. Then the seventh one, a plus b plus c plus b the whole square, it is basis the fifth one. So if you compare the fifth one, you will be able to write it. So you can say it is square of all four first, that is a square plus b square plus c square plus d square. And then we have to create combination of two numbers, that is two groups, that is 2 times AB plus 2 times AC plus 2 times AD and 2 times BC and 2 times VD and 2 times CD as well, basically. So that is the combination of all these numbers. Then after this, the next one, that is a plus b and a minus b. It is a square minus b square. Then the next one is x plus a and x plus b. literally multiply two brackets with each other, you get x square plus ax plus bx plus ab. Now from these ax and bx, what we can do is we can take x common, so we end up getting a plus b x basically. Then we have a plus b the whole cube. A plus b the whole cube is a cube plus 3a square b plus 3ab square plus b cube. Then there is alternate formula also for this one. So the alternate formula is, what you end up doing is you combine the first and the last number. So that becomes a cube plus b cube. And from the middle two numbers, what you can do is you can take 3ab common. So if you take 3ab common, you'll end up getting a plus b as the answer inside the bracket after taking 3ab common out. Similarly, a minus b the whole cube is same as the previous one. This one, the only difference will be alternate plus minus. So you get a cube minus 3a square b plus 3ab square minus b cube. Same we can do for alternate formula as we have done for a plus b the whole cube. That is, we can take first and the last one common, that is together a cube minus b cube. And from the middle two numbers, we can get 3ab common again, but we'll take minus 3ab. So if you take minus 3ab common, you get a minus b inside in the bracket. So you should remember the alternate formula as well as the original formula, because you don't know which identity will be utilized when. So that is the whole idea. Then the next one is a plus b the whole cube, or rather a cube plus b cube. So a cube plus b cube is a plus b first bracket. Then in the second bracket you will have a square minus ab plus b square. Then a cube minus b cube. The first bracket is a minus b. Second bracket is a square plus ab plus b square. So that's the formula of a cube minus b cube. Then the next one is x plus 1 upon x the whole square. Now this is exactly basis a plus b the whole square. So you have to apply a plus b the whole square. So try not to by heart this formula, but rather remember it logically using a plus b the whole square and all the four formulae that we are about to see. So it becomes a square, that is x square, then b square, that is 1 upon x square, plus 2ab. So 2ab mein x and 1 upon x gets cancelled when you multiply them because they are reciprocals of each other. Similarly, x minus 1 upon x the whole square, it is x square minus 1 upon x square, sorry, plus 1 upon x square, because a square plus b square, minus 2ab. Minus 2ab is minus 2 because x into 1 upon x gets cancelled. Then we have x plus 1 upon x the whole cube, that is a plus b the whole cube, and we are going to use the alternate formula, not the original formula. So alternate formula, if you remember, it was a cube plus b cube. So you get x cube plus 1 upon x cube, and then you have 3ab. So 3ab becomes 3 only because x and 1 upon x after multiplication gets cancelled out. And then you have bracket mein a plus b, which is x plus 1 upon x. And the next one, the 17th one, it is x minus 1 upon x the whole cube. It can be treated as a minus b the whole cube and the alternate formula. So you get a square, sorry, a cube plus b cube. So you get x cube plus 1 upon x cube and minus 3ab. So it's only minus 3 because a and b, that is x and 1 upon x, gets cancelled. And then you have a minus b, which is x minus 1 upon x, for example. So these are the things that you need to remember basically. So last four formulas specifically, as we are discussing, do not by heart them, try and remember them logically, and you can get these answers straight away in the same manner. Then there are 4 5 random formulae which are utilized anywhere in the calculation. So it is advisable that you remember them as it is, starting with the first one, which is sum of first n natural numbers, which is you have to add 1, 2, 3, 4, and so on and so forth till n. For example, the formula is very simple. It is n into n plus 1 upon 2. Then let's say you want to add first n odd numbers, that is 1, 3, 5, 7, and 9, so on and so forth. The formula is n square. Then you wish to add first even numbers, that is 2, 4, 6, 8, and so on and so forth till n, for example. Then the formula for that is n into n plus 1. Then the next two, the fourth one specifically and the fifth one. The fourth one is you want to add sum of the squares of the first n natural number, that is 1 square plus 2 square plus 3 square, so on till n square, for example. The formula is n into n plus 1 into 2n plus 1 upon 6. And lastly, if you want to add cubes of the first n natural numbers, that is 1 cube plus 2 cube plus 3 cube, so on till n cube, for example, then the formula is n into n plus 1 upon 2 the whole square. So these are the formulae that you need to remember when it comes to some random calculations, and that is the reason it is better that we remember them as it is. Then let's talk about divisibility of algebraic expression. So here there are two scenarios mainly: a raised to n plus b raised to n and a raised to n minus b raised to n. And n has two possibilities: either it can be odd or it can be even. Let's start with the first scenario: a raised to n plus b raised to n when n is even. Now what we can do here is, let's assume the value of n is 2. So it becomes a square plus b square. But unfortunately, since there is no formula for a square plus b square, this type of expression we cannot predict beforehand whether it will be divisible by any particular number or whether it will be not divisible by any particular number. So the idea is the expression may or may not be divisible by any particular factor. We do not know. We cannot comment about this. But the one beside it, that is a raised to n minus b raised to n, when n is even, if you substitute the value of n as even number, any even number, suppose 2 to begin with, the formula becomes a square minus b square, which is a plus b and a minus b. So what does that tell you is that such type of expression will always be divisible by both a plus b and a minus b. Such type of expressions will always be divisible by both a plus b and a minus b. And this is how you can remember that. This is how you can understand that. Then a raised to n plus b raised to n, when n is odd, we can take the value as n as 3. So it becomes a cube plus b cube. And the formula of a cube plus b cube has first term as a plus b. And hence we can say that all such type of numbers, the similar types of numbers, they are always divisible by a plus b, because a plus b is always going to be the factor of those numbers. And lastly, a raised to n minus b raised to n, when n is odd, it becomes a cube minus b cube, and a cube minus b cube is obviously divisible by a minus b. So all such type of expressions are always divisible by a minus b. So why you need to remember is this whole idea, that is, it helps you to find out one factor at least when you are dealing with complex numbers, and that's the whole benefit behind that. And this is the way to do that. And what we are doing is also trying to connect all these expressions with one of our existing formulae only, so that you don't have to by heart anything else or anything separate or anything extra. So even if you are confused, always remember the type and the structure and go back to the reference formula, and you will be able to understand what is happening and what is supposed to be done there in terms of the solving. So that's the idea. Moving on to the next one, that is a cube minus a sorry a cube plus b cube plus c cube, one of the biggest formula that you'll ever see. Formula is similar to a cube plus b cube, so you can keep a cube plus b cube as the reference and look at it in this manner. So here it becomes first bracket a plus b plus c, second bracket a square plus b square plus c square minus ab minus bc minus ac. Now all of this is very very similar to a cube plus b cube, and if you look at that formula clearly and properly, you will understand what I'm talking about. But here in this one, there is one more additional term we have to remember, which is plus 3abc. And now what we will do is, we'll take this plus 3abc and we'll take it on the other side. So on the other side, if it goes, it becomes minus 3abc. And now what we will do is, we'll equate this entire thing with 0. So here, what do we have now? So we have a cube plus b cube plus c cube minus 3abc is 0, which is multiplication of two numbers. Now when multiplication of two numbers is 0, then obviously one of the two has to be 0, and these are our two possibilities. So the first possibility is either a plus b plus c is 0, or the second possibility is that the second bracket is 0. But how does the second bracket can be 0? So for example, the ABC ka value should be equal to each other. Why equal to each other? The moment ABC are equal to each other, this a square and minus a square gets cancelled out, and then we get 0. Similarly, b square and minus b square gets cancelled out, and similarly c square and minus c square gets cancelled out. So we get the value, the underlying condition for second number to be 0 is that ABC all three are equal to each other basically. So this is the way to look at such type of expressions, and these are the two conditions that we have to remember, which we are going to use probably when we are going to solve few questions related to this idea, which is divisibility of algebraic expressions. Now, moving on to the next bit, there are some general formulae we have to derive: a raised to n minus b raised to n. And what we will do is, we'll create two reference scenarios. Either the power is odd or the power is even, for example. So one example we have created as a cube minus b cube, and the other one is a raised to 4 minus b raised to 4. So a raised to 4 minus b raised to 4 can be also written as a square ka square and b square ka square, and that is why it has become a square minus b square, which gives you the idea as a plus b and a minus b basically, which is what has happened here rather. And then this a square minus b square can be again broken down into two things, that is a plus b and a minus b. Now because we are trying to combine these both numbers and trying to find out a connection, common connection, so because a cube minus b cube has a minus b outside, so we'll also keep this a minus b as outside. That means we'll have to multiply this a plus b inside with a square plus b square, and that is what we have also done. We have multiplied second and the third bracket of the second formula with each other, and we have just done few restructures. So we get the answer as a cube plus a square b plus ab square minus plus b cube, for example. Now since we want to write down a general formula, there is one simple idea that you guys can remember, which I am about to tell you right now, and that pattern changing remains the same throughout. So you would see that in the first number, the original power was 3, and we have taken a and b common out as the first bracket. So in the second bracket, it is starting with a square. So we can say it is 1 less than the original number. Here also we can compare a raised to 4, and then it is starting with a cube. So it is 1 less. So here, if our original power is n, it should start with 1 less, that is a raised to n minus 1, for example. Then if you observe further, the value or the power of a further reduces by 1, and then it keeps on reducing by 1 every time, and eventually in the last term it becomes 0, the value or the power of a, for example. Whereas what happens to the power of b? So you'll be curious to know what happens to the power of b. Initially there is no b, so it is 0, but then it is linear term, that is it, the power increased by 1, and then there is one more increase of 1, and the power of 1 becomes the power of 2, for example. So for B, the powers are increasing one by one, and you'll see that the same pattern is happening here as well. Whereas for A, the powers are decreasing and decreasing and decreasing one by one, so that eventually they become 0 in that manner. So combining all of this, if you want to write down a general formula, it becomes A minus B, the first bracket, and the second bracket is A raised to n minus 1, 1 less, B raised to 0, plus A raised to n minus 2, B raised to 1, plus A raised to n minus 3, B raised to 2, and so on, dot, dot, dot. Last number becomes A raised to 0, B raised to n minus 1, for example. So A is reducing 1 part, 1 value, the powers, and it is becoming 0 in the end. And B is increasing by 1 every time till it becomes maximum. So this is the way to do that. Now we have few more variations of the same formula, that is when n is even. Now we discussed taking a minus b out, but right now we are doing a plus b out. So we are going to multiply by a minus b inside here. And when we do that, this is what we end up getting. And again, if we compare, the value of a is 1 less, and then the powers of a are decreasing by 1, and eventually it becomes 0 till the end term, and then the powers of b are increasing by 1, and then it becomes maximum. So initially b is 0, b raised to 0, then it is b raised to 1, then it is b raised to 2, and then it is b raised to 3, b ka cube, for example. So this is the way to remember such type of questions, for example. So formula, very very critical. And this is how we can understand such formula. So general formula, if you want to make for this one, it has to be a plus b, and the second bracket is the power change pattern is same. The only difference compared to previous one is alternate plus minus. So a raised to n minus 1, b raised to 0, minus a raised to n minus 2, b raised to 1, plus a raised to n minus 3, b raised to 2, so on till last number as minus a raised to 0 into b raised to n minus 1, for example. So the suggestion is, do not by heart all these formulae, try and remember it in this manner. Probably it is better, and you can derive it for something else altogether also, all by yourself, without having to rely on them. Then we have next one, the third category, a raised to n plus b raised to n when n is odd. The model type is obviously a cube plus b cube, and the formula for a cube plus b cube is this. So if you want to compare this, again the same story. The powers of a are becoming or reducing one by one eventually, and the powers of b are increasing one by one eventually. And then there is alternate plus minus. The only new factor here is going to be the last term is plus. So compared to the previous one, the formula is exactly ditto same formula, but the last term is plus. And these are the smallest of the things that you have to pay attention to. Otherwise, you'll end up making a mistake here as well. So the formula is a raised to n plus b raised to n when n is odd. The general formula can be the first bracket a plus b. The second bracket is a raised to n minus 1 b raised to 0 minus a raised to n minus 2 b raised to 1 plus a raised to n minus 3 b raised to 2, and so on, dot dot dot. Last term plus a raised to 0 b raised to n minus 1. This is the way to look at all such examples, all such formulae. Again, if you see, what we are doing smartly is we are trying to correlate with one of the given formulae that we have previously done, so that ideas become simple and easy to understand and execute further. Okay, now moving on, last bit, binomial expansions. So binomial expansions, there's a formula that you have to remember, that is a plus b the whole raised to n. It is nc0 a raised to n b raised to 0. plus nc1 a raised to n minus 1 b raised to 1 plus nc2 a raised to n minus 2 b raised to 2 and so on and so forth till the last term becomes ncn a raised to 0 b raised to n. So again you will see the same thing. The powers of a are reducing by 1 each, eventually becomes 0 till the last term. The powers of b are increasing by 1 each and eventually till the last term becomes highest, the maximum one. This now NC0, NC1, NC2 is something that you're going to see in permutation combination, and we'll discuss that at that point. So as of now, you're going to keep it as it is because you do not know how to simplify those values at this particular stage. So we'll keep it as it is. Now coming back to the basics, any expression that we have discussed. So for example, we have discussed couple of formulas so far which belongs to these all types. So for example, a plus b the whole square. It is a square. It is a square plus b square plus 2ab. Then we have also discussed a plus b the whole cube, and it is a cube plus 3a square b plus 3ab square plus b cube. Now you'll observe something. When the power is 2, there are a total 3 terms in the expansion. When the power is 3, there are a total 4 terms in the expansion. So here the power is n. So automatically, how many terms should be in the expansion? N plus 1 terms are supposed to be in expansion. So always remember that the power decides how many terms the expansion will have in overall. So if the power is n, the overall terms will be n plus 1 of the expansion. That's a buffer that you can remember. Now, assuming that the first term is t1 and the second term is t2 and t3 and so on, the last term is n plus 1. Each of these terms are also supposed to be represented by something raised, something with r plus something, r plus 1 format. So the first number becomes r plus 1, that is r becomes 0 basically because 0 plus 1 is 0. Sorry, 0 plus 1 is 1, my bad. Then the second term t2, it should be also be represented with the help of r plus 1. So here r becomes 1 because 1 plus 1 is 2. Then for term 3, T3, R has to be 2 because 2 plus 1 is 3 and so on so forth. So why we are doing all of this? Because then you have to remember a formula for any number that you wish to find out or any term that you wish to find out, and the formula is denoted by this, that is TR plus 1, the one that is highlighted as of now in the bottom part of the screen. So it is TR plus 1 NCR A raised to n minus R B raised to R. This is the formula that you need to remember for finding out any particular term. So here the data and everything will be very clearly mentioned. All you have to do is some calculation, some two calculation plus rearrangement. And then there are specific types of questions that are asked on binomial expansion. I think we're going to cover all three of them so that there are no surprises for you when you are talking about binomial expansion. So let's say if the data is given, so you would know A, you would know B, you would know N, then obviously you will know the value of R also because whichever term you want to calculate, you just have to do minus 1 to get the value of R, for example. So that's the way to look at binomial expansion. Now, these are all the concepts that are required for doing this idea of operation on numbers. Now let's start with the questions. So starting with the first one, here is the question. So again, I would request you all to pause this video as of now and try this by yourself, and we'll discuss in some time. Okay, so I hope you have read this question, and now let's try and solve this. So obviously the first part is the priority orders. So the priority orders, clearly there is a vinculum, and vinculum always has the highest priorities. So we are going to use that. So vinculum is present on 3 minus 2. So clearly 3 minus 2 we have to solve first. So 3 minus 2 is obviously 1. And if now imagine if they would have not given us this vinculum on 3 minus 2, normally we will simplify it the last. But that is the whole idea behind priorities. We have to use them as it is in the order that is mentioned. So hence we are using that. So 3 minus 2 becomes 1. Vinculum is done. The next one is B, which is brackets. Unfortunately, there are no brackets. So we'll skip that out and we'll move on to the next one. The next priority is off. So off is usually multiplication. So we have to simplify these all numbers. So 3 of 4 is 12. Then this is 7, sorry, this is 8, 2 of 4, and this is 2 of 7 is 14, for example. So that's your next priority, which is off. Then comes division and multiplication. So division and multiplication would have somewhere here, then we'll have here, and then we'll have here. So let's do that. 4 divided by 1 is 4, and 4 into 4 is 16. Then this is 1 divided by 8. I'll keep it as 1 by 8 only. And then this is 6 4s are 24 divided by 14, which after simplification can be rewritten as 12 by 7. Then in the end part, what we are going to do is we are going to do the addition and subtraction, the last part of the calculation. So that becomes 2 minus 12 plus 16 plus 1 upon 8 minus 12 by 7. 24 by 14 is 12 by 7. So this becomes 2 minus 12 is minus 10, minus 10 plus 16 is plus 6. So this becomes now 6 plus 1 upon 8 minus 12 by 7. What we have to do is obviously take LCM and then simplify the numbers. So 8 and 7, the LCM is 56. So this becomes 6 into 56 plus 1 into 7 minus 12 into 8, the common denominator 56. So this becomes 336 plus 7 minus 12 8s are 96. So that is 343 minus 96 upon 56. So I think this becomes 247 upon 56 as the final answer, which is yes, answer option 1. If you check your handouts, answer option 1 is the answer for question number 1. So this is the way you apply the priorities. Purposely I have done color coding so that you understand the difference as and when it is given, basically. So this is the way to follow the priorities, and hence this is the first question, basically. Let's move on to the second one. It says x square plus 1 upon x square is 66. Then find the value of x minus 1 upon x, for example. So we know the formula of x minus 1 upon x the whole square. It is same as a minus b the whole square. It is a square plus b square minus 2ab. So it becomes x square plus 1 upon x square minus 2. It becomes, because x and 1 upon x gets cancelled into ab wala term. And now comes the best part. x square plus 1 upon x square is known to us, which is 66. So if we substitute here the values, it is 66 minus 2, which is 64. But then look at what has happened. We have the answer for x minus 1 upon x, the whole square. And that answer is 64. Whereas we wanted only x minus 1 upon x. So you have to get rid of the square. Now how do we get rid of the square? So we do square root. And if we do square root on the left side, we have to do square root on the right side also. So obviously 64 ka square root is 8. And I think answer has to be 8 for this particular question. 5 for you. This is the way you can solve this. X minus 1 upon x, the value is 8. So formula was known to us. All we have to do is simplify. Then question number 3. We have been given the value of a plus b and ab, and we have to find out the value of a cube plus b cube. For that you need to remember the formula for a cube plus b cube. Original formula is this: first bracket a plus b, second bracket a square minus ab plus b square. So you have a plus b, which is 13, and you have ab, which is 25. But you do not have a square plus b square. How do we get this? Now, see, these are the things you have to understand. So, you have to know the formula for a plus b the whole square. It is a square plus b square plus 2ab. So, from here, what we can do is we can rearrange this formula and get the value of a square plus b square, for example. How do we do that? So we simply have to take this plus 2ab on the other side. So it becomes a plus b the whole square minus 2ab, and we get the formula for a square plus b square. So again, you know a plus b, which is 13. You know ab, which is 25. You solve this, you're going to get the value. You substitute, then you simplify, you get the answer. Now this is one way to get the answer of a cube plus b cube, for example. Then there is other way, and this is critical, why you have to remember or understand all the formulae. How do you otherwise get a cube plus b cube from somewhere else apart from the original formula? So if you remember, there was the formula for a plus b the whole cube, the alternate formula to be precise. It was a cube plus b cube plus 3ab and bracket के अंदर a plus b. Why this formula? Because directly you will get all the answers, because you know a plus b, that is 13 ka cube. You have to find out a cube plus b cube, which you will be able to get it. Then 3ab, that is 25, and then a plus b is 13 again. So this is 75 into 13, which is 975. So a cube plus b cube is gonna be 13 ka cube. Now see, 1 to 20 के cubes आने ही चाहिए. 2197 minus 975, you get it as 1222. Answer option 3. The same answer you would have got here also, but you have to remember this hack then. How do we get the value of a plus b the whole square? From detouring, how do we get the value of a square plus b square? From detouring a plus b the whole square ka formula. So these are the ways in which you can understand and remember stuff. So the more important thing is you have to remember multiple formulas, so that whichever whenever required, you can simply substitute, solve, and get your answers basically. So these are the initial 3 questions. Now let's talk about the next one, that is binomial expansion related 3 questions. The first one is this. So they have given us the expression. It is 3x square plus 2 upon x cube the whole raised to 20 there are only three types of questions that are asked on binomial expansion, and we are covering all three of them. So you should not have any issues going forward. So the first type that they can ask always is find the middle number. So to find the middle number very clearly, you first have to know how many terms are there in all. So the value of n is 20 here, and if you remember the formula or the concept that we have discussed earlier, the total number of terms are always n plus 1. So here there are 21 terms overall. Now, if there are 21 terms overall, the middle number has to be the 11th number. The logic is very simple. 10 numbers on other side, 10 numbers on other side. The middle one is the 11th one, and hence there are 21 numbers overall, basically. So point is, if we are supposed to find out the middle number, in a way they are asking us to find out the 11th term. And again, for this you have to use the formula of TR plus 1. And you should know now again that for 11th term, the value of R is going to be 10, for example. So let's substitute the values in the formula. So TR plus 1, the formula is A raised to TR plus 1. The formula is NCR A raised to N minus R and B raised to R. So you know everything. Look at this formula and then look at the substitution part here. All we have to do is restructure. This 20C10 remains as it is. Then this becomes 10 and 3 raised to 10, and then it becomes x raised to 20 because laws of indices 2 and 10 will multiply. Same goes here. This is 2 raised to 10 and then 3 and 10 will be multiplied and you get x raised to 30. Then last step now, x raised to 20 divided by x raised to 30. Obviously x raised to 20 cancels out from both the terms and you are left with x raised to 10 in the denominator. So we are saying this is the middle number, that is rather 11th number, and all we have to do is find out from the options which answer option does this belong to. So clearly it belongs to the first answer option of question number 4. So the 11th number or the middle number or the 11th term is this one. So all you have to do is first understand how many terms are there and then find out the middle number using the formula of TR plus 1. You know everything, you know A, you know B, you know N. All you have to do is substitute, calculate, simplify. You get the idea. So that's the fourth one. Let's talk about the fifth one, which says, same question. They are asking find the term that is independent of x. Now, unfortunately, there is no way for you to remember or understand that beforehand that the term independent of x is which term. So, if you do not know the term, you would not know the value of r. Unlike previous number, you know that the middle number is 11th number, so you could figure out that r is 10, one less than that. But here, because we do not know the term, we do not know the value of r. But we can still apply the same formula, that is tr plus 1, which is ncr a raised to n minus r and b raised to r. Let's again rearrange the terms a bit and keeping the constant terms together and the variables together. So x raised to 40 minus 2r, because x raised to 2 and 20 minus r will be multiplied, and x raised to 3 and x raised to r will be multiplied, which gives you x raised to 3r. Now we are saying this is the term that is independent of x, which means x should not be present here. That means x should be cancelled out from both the scenarios. Now when do we normally cancel out things? So obviously assuming that they are equal. So the terms are equal, hence we cancelled out them. And when we cancelled it out, we get 40 minus 2r is equal to 3r, which gives us 40 is equal to 5r, and that gives us r is equal to 8. And if r is 8, obviously which term it is going to be? So it is going to be the ninth term, which is term independent of x, which is answer option 2 for that matter. So these are the things that you need to understand when you are dealing with such questions. So term independent of x, you would not know that beforehand. Keep solving, keep substituting. And in the end, just simply strike out x from both numerator and denominator. And when we can do that, assuming they are equal. And equate, you'll get the value of r. Once you have r, you know the term. So term independent of x. Remember that as a concept. Then there is sixth one which says for the given expression, find the sum of the coefficients. So for here, we need to go back to binomial expansion a bit. Now try and understand people. We want to only find out NC0, NC1, NC2 and till NCN, for example. That is the sum of the coefficient. Which means what? We are supposed to get rid of these variables. And what is the fastest way to get rid of these variables? Then substitute them as 1 each. Why? Because 1 raised to anything is 1 only. And when you do that, automatically what is going to happen is on the right hand side, if you substitute a and b as 1 to get rid of them, the powers, on the left side, you should also put them as 1. So 1 plus 1 becomes 2, and this becomes 2 raised to n is equal to nc0, nc1, nc2, and so on and so forth. So remember this concept, remember this formula that we are doing right now, and it will be used later on in permutation, combination, and probability. I know it's a long journey from numbers to permutation combination, third module to last module, but try and remember this because the connection will come there, and uh, this is the back end concept of the conclusion that we are going to see at that point. So coming back to this, always in binomial expansion, if you ever wish to find out the sum of the coefficient, the simplest way to do that is what we have done right now, a and b as 1, that is put variables as 1. Now coming back to our question, in our question the variable is x, so that means we are supposed to substitute the value of variables, that is a and b, as x. So x is 1 for us, and if we substitute that, we get the answer as 5 raised to 20 straight away, which is answer option 4 in this particular manner. So you have to remember this. In binomial expansion, if they ask you sum of the coefficients, all you have to do is substitute the variables as 1, that means x as 1, and you get your answer straight away. So these are the three questions that can be asked when it comes to binomial expansion. Now, let's talk about question number 7. 7 raised to 6n minus 6 raised to 6n, where n is the integer. How do we solve this? So, see here what we need to understand or remember, that we have to use divisibility of algebraic expression, and you can consider a and b as 7 and 6 itself. So this becomes a raised to n minus b raised to n when n is even, because 6n is even. And we know this type is divisible by both a plus b and a minus b. Why? Because it becomes of the type a square minus b square, basically. That's the reason. So we can say our expression is divisible by both a plus b and a minus b, which is 7 minus 6, which is 1, and 7 plus 6, which is 13, for example. and that option is also present, option 1 13. But why you should investigate more, the simple reason for that is the options that are given. So I can see in the handout that there are some options which are saying 1 and 3 only, or some options are saying 1 2 and 3, and so on and so forth. So that is the reason why we need to probe a little more in such type of questions. And what we can do now is, instead of taking a and b as 7 and 6 straight away, and then taking the power as n 6n, we can split that power using laws of indices. So we can write the same thing also as this as well, where again the formula that we have used here is a raised to m the whole raised to n, it becomes a raised to mn. The powers will multiply. So 3 and 2n multiplication gives you 6n, the same original number we have. Now this is again of the same type, a raised to n minus b raised to n when n is even, and hence it is divisible by again both a plus b and a minus b. Same story. So the only difference will be here, that is the a and b are not 7 and 6, but it is 7 cube and 6 cube. So it is divisible by both 7 cube and 6 cube ka sum and difference. So 7 cube is 343. 343 minus 2 and 6, it is 127. And 7 cube is 343 plus 216. So that gives you 559 as the answer. So point is, it is divisible by both 13 and 127 and 559, all three numbers rather, not both. So that means answer option 5 is the correct answer, which is 1 2 and 3 respectively. So these are the ways in which you can think about such type of questions. The construct is very important. First, you need to identify the type, and then basis the options, you need to think extra to figure out how to go about it in a particular way. Okay, moving on. Question number 8, which says n is a number which is defined as 17 cube plus 55 cube minus 72 cube. Then n is divisible by what? Now here we can say that it is of the type a cube plus b cube plus c cube, but only thing that will happen is we have to rearrange it now like this. From here we need to rearrange it here, then it becomes a cube plus b cube plus c cube. The only difference is our c is minus 72. That's the only change. Originally, if you remember, you had a cube plus b cube plus c cube minus 3abc as 0. And when you solve this, you get a cube plus b cube plus c cube is equal to 3abc. But we are saying it is minus 3abc for us now. Why? Because the c ka value is negative for us, and hence the product is negative. This is the original construct. But since we have modified our question to the suitings, the change has to be reflected as well. So do not think as a some error or a printing error. It is not. It is the consideration of the actual number, because the one of the number is negative, so the product becomes negative minus 3. Also, all of this, or this rather, is gonna be true when you had two scenarios. Either the three numbers are equal, or the sum is 0 for them. Again, if you compare, if you go back to our numbers are 17 and 55 and minus 72. Are they all equal? No. But we have to check the sum, that whether the sum is 0 or not. And when you do that, you end up realizing that yes, the sum is 0. So that means the condition is matched, and if the condition is matched, then instead of these numbers, we can we can rewrite them as something else. We can rewrite them as 3abc, for example. Here it is given. So instead of a cube plus b cube plus c cube, we can write them as 3abc. And now all we have to do is check the options. So 3 and 17 is there. This can be 11 into 5. This can be 8 into 9. Now the options are, the first option is both 7 and 13. I cannot find 13, so that is off. Then 3 and 13. Again, I cannot find out 13. Then 17 and 7. I can't find 7 here. Then there is 3 and 17. And yes, I think this is where it is going to be matched. So the entire expression is going to be divisible by 3 and 17, which is answer option 4 for this particular question. And that's the way to do that. So again, the philosophy remains the same. Divisibility of algebraic expression, you have to know that, and then the calculation part is equally important. Now, if you have understood this one, let's go to the next one, which is we have to solve for this. That is 1 square plus 3 square plus 5 square plus so on till 99 square. Unfortunately, there is no formula for that. So it's a very specific type of question and has to be done like this only. Otherwise, you'll not be able to get the answer. So first what we can do is we can add all the 100 numbers ka square ka sum. And from that we can subtract the even numbers ka squares ka sum. So whatever will be left will be what we want. That is 1 square plus 3 square plus 5 square and so on and so forth. Now all we have to do is do the calculation. For the first part we have the formula, that is okay. That if you remember the formula, it is n into n plus 1 into 2n plus 1 upon 6. So 100 is the value of n for the first half. But now again for the second half there is no formula. So what we can do is we can take 4 common out. Why 4 common out? Because the first number is 2 square, which is 4 itself. If we take 4 common out, it is 1 ka square. Second term is 4 square. If you have taken 4 out common, the left inside number is 4, which can be written as 2 square. Then we have 6 ka square, which is 36. We have taken 4 common out. So 36 divided by 4 is 9. 9 can be written as 3 ka square. And so on. The last one is 100 ka square, which is 10,000. 10,000, if you take 4 common out, you are left with 2,500, which is 50 ka square. So again, we can apply the formula that we have discussed in both the aspect. The only thing is one time n is 50, the other time n is 100. So that's the calculation that is going to be painful. But there is no other way to do this. So 100 into 101, 2n plus 1 is 201 upon 6 minus 4 into similar picture 50 into 51 into 101 upon 6. How do we solve this? So here we can take 100 and 101 as common. Okay, upon 6. So if I have taken 100 and 101 common, the first bracket only 201 is left. But how I have taken 101 and 100 as common, so here it is 4. So it can be 2 into 2. 1 2 I am putting inside with 50 and 52 is 100. So that gives me 100 and then 101. So left over is only 2 into 51. The smart thing has to be clicked again in such type of questions. So this becomes 100 into 101 upon 6 and then 201 minus 102. How much that is? That is I think 99. Yeah. 99 is divisible, let's say, by 3. So 2s are 33. Yeah. And it's 2 divided by 50. 33 into 5 is 165 into 101. Okay, now how do we do this? So this can be broken as 100 plus 1. So 1650 into 100 is double zero. Then one more ones are so 1650. 1,66,650 is the answer. The reason is I split that as 100 plus 1. Then multiplied, simply added basically. This is my answer. These 1,66,650. I don't know what is the correct answer. Let's check. I am hopeful that I have done the calculation correct. Not very sure. Yeah, super. 1,666,500. Great. None of these. So the calculation part is also equally important in such kind of question. The thought process is very important, which is what you need to understand while doing such complicated calculations. Make it simple, and then it's not that you'll always get it right. Initially you'll make more mistakes, but then over the time you have that uh, intuition to think in a particular way to figure that out. Okay, so that was the ninth one. Let's look at the next one. Very interesting. It says 2 raised to 33 plus 1 is exactly divisible by a number, let's say x. And then which of the following is also divisible by the same number? Very simple idea. If it is has to be divisible by the same number, then it should belong to the same type. If it is of the same type, it will be divisible by the same number because that's what divisibility of algebraic expression says. But here the very important idea for you guys to understand is the the values. So 2 raised to 33 plus 1 can be also written as 2 raised to 33 plus 1 raised to 33. Why? Because 1 raised to anything is 1, and this becomes of which type? So it is a raised to n plus b raised to n when n is odd, and it is always divisible by a plus b because a cube plus b cube is the example, is the structure that it becomes. Now, if this number is divisible by x, then obviously the options one should also be of the similar type to be divisible by the same number. So the first one, 2 raised to 66 plus 1 can be written as 1 raised to 66. The problem is the power. The power is not odd. The power is even. So it is of not the same type. We want power to be odd. Here it is minus instead of plus. The power is odd, but the sign is not plus, it is minus. So it is not of the same type. Then this 22 is of the same type. Power is even, not of the same type. Then this clearly not of the same type. Obviously has to be this. Why? Because it also belongs to the same type. A raised to n plus b raised to n when n is odd, because 99 is odd and sign is also plus, and it will also be divisible by the same number. So answer option 5 is the answer for a 10th question. So see, if you remember right things at right point, you can do questions like that, just like that in under a minute, 30 seconds stops, 40 seconds stops, and save that time and use it somewhere else valuably. For that, you have to know that practice. That skill will only come when you practice because the brain is wired to think or remember certain things in a certain way, which is the most critical aspect. Okay, so that's about operation on number. So we are done for today. Go through this all over again, lots of formulae. And if you still have any queries or any questions, do let us know. We'll be happy to help you guys. So have a great